It's time to start plotting our data. So our first task is to produce a visual that depicts lung cancer deaths and smoking rates over time. Now, at first glance, it might be tempting to call plot again using the lung cancer deaths data column. Why don't we try it and see what happens? So for example, we just plotted out before our year on the x-axis and our percentage smokers on the y-axis. I'll create another variable called y-axis cancer and set this equal to smoking data. And our column name is age-adjusted lung cancer deaths. And then I'll copy this plt.scatter and paste a second one where we plot x-axis and then y-axis cancer. Let's see what happens. Well, we have plotted smoking rates and lung cancer deaths on the same plot. However, we have some issues. First, which of the scatter plots represents lung cancer deaths? Which of the scatter plots represents smoking rates? Our y-axis has been labeled for percentage smokers only. We don't have an axis for lung cancer rates per 100,000. So we need to fix these issues, A, by including a data legend, so in other words, which markers represent which data, and B, we need to either add a secondary axis, a secondary y-axis, or we need two graphs that have a shared x-axis. Well, let's address the first issue, the data legend. And this is an easy one. To display a data legend, first we provide labels for our plots, and then we call the legend function to display our legend. So let's try this. On plt.scatter, our first scatter plot, I'll include label equals percent smokers. And on my second plt.scatter, I'll specify label equals lung cancer deaths. And then after my plt.title, I'll add in plt.legend. And if I run this code, you'll see that we have a data legend. In order to display both the percent smokers and lung cancer deaths over time, we're going to investigate a technique that allows us to create two graphs stacked on top of each other with a shared x-axis. In order to do this, we'll need to use the subplots function instead of the figure function to tell matplotlib how many graphs are going to be within the graph we're about to create. This is known as creating small multiples, or two subplots in the same x-axis. So in this example, we're going to create a graph with two plots, one stacked on top of the other, with a shared x-axis. Ready? Let's go. We'll come back into Python. We'll come back into our code. We're going to change things around. First, we're going to create our subplots. We'll say fig, axes equals plt.subplots. We're going to create two horizontal plots in one column. They will share the x-axis, and my figure size is going to be 12 inches by 7 inches. Next, we're going to use our axes, or axes variable, to plot our scatter plots on our subplots. So here's how our code is going to change. We're going to keep the x-axis and y-axis cancer. This does not change. We're going to remove this plt.figure. plt.scatter is going to change from plt.scatter to axes0. So the item, the axis at position 0, so we use square brackets, dot scatter. We're also going to change our Y label down here. We're going to move this up here, just below the AXES bracket 0, and we'll change this to AXES square bracket 0 dot Y label. And then we want to set, instead of calling Y label, we call set underscore Y label to set our first plot's Y-axis label. And then finally, we need to say AXES 0 dot grid to provide our grid lines for our top axis. We're going to repeat this process for our lung cancer deaths. So instead of AXES 0, we'll do AXES in brackets 1 for our lung cancer deaths. We'll do AXES square bracket 1 dot set Y label. And this will be lung cancer deaths per 100,000. And we will also call AXES 1 dot grid to provide grid lines. We're going to get rid of the PLT dot legend because our Y-axis labels will provide us with context. We can get rid of PLT dot grid. And then finally, to show our final result, we call PLT dot show. And if we run all this code, we see that we now have our smoking rates in Canada by year. Now, we have a slight issue here. Our title appears between our two plots. We actually want to move this title up above the first graph, so we're going to modify this to say AXES 0 dot set underscore title smoking rates in Canada by year. And we will remove this PLT dot title. And if we run this code again, we now have our title at the top of our first plot. Now, there is a fair amount of space between our two plots now, and it can make it hard for the reader to line up years between our plots. After we call subplots, we can use the subplots adjust function to remove that horizontal space by saying fig.subplots_adjust h space equals 0. Let's try that. So we'll say fig.subplots underscore adjust h space equals 0. And if we run this code now, we see that there's no more space between these two plots. Now, we should probably give this data a little bit more context. And we've got some more customizations we can take advantage of. First, we can adjust the colors of our data points via the color parameter of the scatter function. We can also customize the marker type. For example, we can substitute our circles for squares. We can also specify how thick or how large our data points are with the line widths parameter. We can adjust the font size of our axes label via the font size, pad, and color parameters, and we can toggle bold on axis labels via the font weight parameter. Let's try that now. So I'll come back into Scatter. Say I want to adjust the color of my scatter plot. And in this case, I'm going to change this to be a dark orange. I can say color equals dark orange. And if I want to make the markers much larger, I can say line widths equals 5. I can do the same thing for my second scatter plot as well. I can come down here, after label, put in a comma, say color equals blue, and line widths equals 5. I can also customize the marker. I can say marker equals greater than sign, and that will give me triangles. All the different marker types are referenced in the slides. There is a website you can go to, the Matplotlib website, and it lists all the different types of marker customizations. Finally, we can make our plot Y labels. We can customize these. For example, we can say weight equals bold to make our Y-axis labels bold. Same with our X-axis. There's many customization options, and I recommend that you check out the documentation for Matplotlib to see what you can customize on your plots. So we've now created a scatter plot of smoking rates versus lung cancer deaths. In the next video, we'll look at how to create a line graph of smoking rates and lung cancer deaths over time.